this is an equilateral triangle. Equilateral triangles are defined by the fact that all of their sides are of equal length. It can also be defined by the fact that each of its internal angles are the same. So because the angles of a triangle are 180 degrees, each of these angles must be 180 degrees divided by 3, which is 60 degrees. That also defines an equilateral triangle. What is the area of this equilateral triangle? Well, we can normally find the area of any triangle with the equation 1 over 2 base times height, or half base times height. The problem with this particular triangle is that we don't have the height. This isn't a major problem because we could use an alternative equation. This one, for example, root 3 times the length squared over 4. We're going to be looking at why it can be used to calculate the area of an equilateral triangle when you don't have the height. We are going to arrive at this equation by using half base times height. So for the moment, let's hide this equation and let's show the half base times height because we'll need it for guidance. The first thing I want to do is draw a line from the tip of the triangle to the base, a vertical line. Let's do that. I've used a line to bisect the top angle. This line is normally called an angle bisector, and what it does, it splits the angle into two equal parts. So a 60-degree angle becomes two 30-degree angles. We've also created two triangles with this split line so that each triangle has a 30-degree angle and a 60-degree angle. We can figure out the remaining angle. Let's call that angle x. We know that x plus these two angles must equal 180 degrees because the sum of angles in a triangle add up to 180 degrees. But these two, 60 and 30 degrees, add up to 90 degrees. So that means x plus 90 equals 180 degrees. Well, x must be 90 because 90 degrees plus 90 degrees equals 180 degrees. So x equals 90 degrees. This is very useful to us. So looking back at the basic equation for the area of a triangle, we notice that we need the base. The base is just the length of any of the sides of the equilateral. So let's write that here. And then we need the height. Well, the height is the dotted line which goes from the top of the triangle to the base. Now, the issue still exists that we don't know the value of height, but here's where the right angled triangle is beneficial because we can use trigonometry to get values for a height using the degrees in the triangle. So let's do that. We're going to use 60 degrees for this. Hopefully you know that the sine of an angle equals opposite over hypotenuse. We're using 60 degrees, so let's put 60 in there. Sorry about that. So sine of 60 equals opposite. Well, opposite is the height of this triangle over hypotenuse. Well, the hypotenuse is just the length of one of the sides. So it's height over length. If we want the height, we would have to multiply both sides of the equation by L. And that will give us L times sine 60 equals the height. So now we have the height. Let's put that over here. And now that we have base and height, we can apply those values to the equation for the triangle. So the area of the triangle would be 1 over 2 base, or half base. Well, we know the base is L, so that equals L over 2 times the height. We know the height is L times sine of 60. We can simplify this a little because L times L is L squared, so that will be L squared over 2 multiplied by sine of 60 degrees. You'll find that sine of 60 equals root 3 over 2. So then this becomes L squared over 2 times root 3 over 2. We can simplify even further. If we take the denominator first, that's 2 times 2, which is 4. Then it doesn't matter which way around you have the values in the numerator, so I'm going to put root 3 first and multiply by L squared. Looking back at the original equation, you can in fact see that it is exactly the same thing. This is what we were looking for, and by going through all of those steps, this is what we arrived at, which is the area for an equilateral triangle. So now you know why this equation must give you the area of an equilateral triangle if you don't have the height, but you just have the length.